Hello and welcome to this lesson where we're going to dive into one of the core concepts of working in Python. And in this lesson, we will see how we can work with numbers. Now, in Python, we have three numeric types. We have what is called an integer. So if I create here quickly a variable called number underscore int, an integer is going to be a whole number, so something like 10, 20, 100. Anything that is a whole number is considered an integer. And then you have what is called a float number or a floating point number. And this has a decimal point. So 10.0 is going to be a float number because you have the decimal point here. So for Python, although for us this looks like the same number, for Python we're working with an integer, and this here we're working with a float number. And then the third type is what is called a complex number. And to create a complex number, we put our whole number here, and then we put the letter J, which is going to represent the imaginary part. This is not something that we have to worry about for this workshop because we're not going to use it. This is used mostly in scientific fields, so we can ignore this completely. We're just going to focus in working with integers and working with floats. I know I already mentioned this in different lessons, but I just want to recap again because this is something quite important when we want to check the type of data we are working with. And the reason why this is useful is because sometimes we have the variable and not necessarily understand what is the data that we're getting in return. So using the type, we are going to get information working with the integer, and if you replace with the number float, say it's going to work with the number float. And if I remove this and put the J to get the complex number, there you go. You see we're working with a complex number. So get back to our floating number. And one thing that I want to talk about before we move into the arithmetic operators is how do we write large numbers. So if you want to write 1000, that's it. It's easy to understand what's happening here. But if you want to write 1 million, you put another 3 zeros. It becomes a little bit difficult to read. And then if you want to go to 1 billion, so another 3 zeros, so 1, 2, 3. Now this, for us, it starts to become difficult to understand what exactly is here. And we only have zeros here. Like if we have different numbers, it becomes even more difficult to do it. So when you're writing these type of numbers, we tend to put a decimal point between the zeros just to help us to read this number a little bit easier. So something like this, immediately we understand what type of number we're working with. This is not something that we can do in Python, because if you try to print this, as you can see here, we're going to get an error, so there's a syntax error. But what we can do is we can replace the dots with the underscore. So if you do something like this, it's still easy for us as humans to read. And Python is going to completely ignore the underscores that we have here and just going to print the number. So if I do the type, so if I remove this, put number int, you'll see that now we have the whole number without the underscore. So just a quick tip to see how we can work with large numbers. So now that we're going to check the arithmetic operators, I'm going to delete this and create two very simple variables. We can do something like this. And obviously addition, subtraction, multiplication, and division, I think this is quite obvious. We don't need to go through this. You know, the addition is going to add the two numbers, subtraction is going to subtract, multiply, same, division is same. But then we have here the floor division, the models, and the exponentiation. So how exactly this works? Well, let's put our variables here, and let's start with the division. We all know that 10 divided by 2 is going to be 5, okay? But then let's see what happens when you work with, for example, 10 divided by 3. We're going to get 3.333. Okay, cool. So let's see what happens with the floor division. The floor division is 2//. And when we click apply, we are going to get the number 3. So what exactly happened to the decimal point and all this long number that we have after the decimal point? What was going to happen when you're working with the floor division is that we are going to ignore this section and we're just going to get the whole number, the integer value that we have here. So even if I change this, for example, to something like 8, you'll see that the result is going to be 2, despite the fact that 8 divided by 3 is going to be 2.6. And then we have what is called the models. So the model is going to work slightly different. If I remove these forward slashes and I put the percentage sign, you'll see that 8 by 3 is going to be 2. So what exactly happening here? Well, if you think about how many times can we have the number 3 inside the number 8? Well, if I do the math here, you'll see that we can put 3 once, and then if you put another 3, it's going to be equal to 6. But then if you put another 3, you're going to have the number 9 now, right? So that's what's happening. So when you're doing the models, we're getting the remainder of a division operation. So that's what's happening here. If I change these, for example, to 6, then you'll see that the result we're going to get is going to be 0, because we can put 3, and then if we put another 3, it's going to be 6. So there is nothing left. If I change these to 7, we are going to get 1 as a remainder, because then after the 6, we can put 3. We cannot put another 3 inside the 7 because there is no space. So the remainder is going to be 1. And you'll see that's what's going to happen here. Why is this useful? Because sometimes we need to check if a number is even or odd. And if something is divided by 2, this is going to be 1, so that means this is an odd number. If something is divided by 2 and you get 0, this is going to be an even number. So this is one practical application of working with the models. And then finally, we have what is called the exponentiation. So what the exponentiation does is to raise a number, which is known as a base. So for example, the 4 is going to be a base to the power of the exponent, which in this case is going to be 2. And this is going to get a result of 16. The practical aspects of this operation is related with things that we're not necessarily going to cover in this workshop, more to computer graphics and game development, data analysis, where they use quite a lot the exponentiation. But for us, I think we're probably just going to stick with the addition until perhaps the models, which is going to be useful to check, like I mentioned, the fact that we're working with odd or even numbers, or just getting the whole number from a division that's going to get a decimal point. Now let's talk about working with the addition, subtraction, and multiplication assignment. So what exactly can you do with these? For that, I'm going to clean our code here. I'm going to create a variable called x is going to be equal to 0. And then I have a loop, a for loop. And I'll say that for y in range, the number 10, and what this is going to do, this is going to run the loop 10 times. I'll say that I want to print the value for x, but then at the end, I want that x is going to be plus equal to 1. So see what happens here. When I click apply, you'll see that we start with the value 0, which is a value that we have here initially. And then by the end of this loop, we are going to add another value. We're going to add 1 to 0. So that means when the loop starts again and I'm going to print x, the value is no longer 0, it's going to be 1. And so when I reach here at the end of the loop for the second time, it's going to add another 1. So it's going to make the value of x 2, and so on, until you reach the end of the loop. You don't have to use 1. I mean, if you use 2, you'll see the result is going to be the same. Click apply. You'll see that we start with 0, then the next value is going to be 2, then the next time the loop runs is going to be 4, 6, 8, and so on. Obviously, this works as well when we work with subtraction. So if I say that the value is 10, and then I want to subtract 1 every single time, then we're going to get precisely the opposite that we had initially. So click apply. You'll see that we start at 10, 9, 8, and then we reach to the number 1 because we're subtracting. If you use the multiplication, well, I think you get to how it works. We'll get with 10, and then it starts to multiply until you reach to the last number. A practical example of this is when we're working with, let me show you here, merge nodes. The index for the merge node, the first index, is going to be 0. So if I dropped a cube, for example, and I connect it, the first input is going to be 0, and then the second one is going to be 1, and the third one is going to be 2, and so on. And then we can use this in a script where we go through the nodes we're creating and we're connecting them through a merge. The initial value for the index is going to be 0, and then what's happening is that every time we go through creating the nodes, we then add a value, so plus equal to 1, meaning that the next index is going to be 1, 2, 3, 4, so on, depending on the amount of nodes we're going to connect. This is going to make a lot more sense once we get to the batch importer, where we're going to pick up all the nodes we are importing and connect them into a merge node, and you're going to see this in action. Let me now just go back here, delete this, and now let's talk about working with some built-in math operations that we have. If I delete this and say import math, we have a couple of math operations I think is going to be useful, and that's the reason why I'm mentioning them here. If, for example, we have a number that's going to be something like 2.5, and we need to round up this number, and then we can use a function precisely for that called round. And then if you put your variable here and just giving a couple of more lines, when you click apply, see what happens. We get the number 2. And this can be a little bit counterintuitive initially, because we would be expecting that rounding up this number would be 3 and not 2. So why is this happening? Well, Python uses something called the rounding to the nearest even number, also known as the Banker's rounding. So that means in a situation like this, 2.5, the closest or the nearest even number is going to be the number 2, because the next number, if you're going to round up, is going to be 3, which is odd. And if you change these to 3.5, you'll see that the nearest even number is going to be 4, and that's exactly what we're going to get. But if I say that this is 4.5, the nearest even number is going to be 4. It's not going to be 5, because 5 is an odd number. So when you click apply, you're going to get 4. If I change these to 5, the nearest even number is going to be 6, and that's why we're going to get this. The reason why the round function works this way is because it's trying to reduce the cumulative error that can happen when we perform multiple rounding operations on a large database. And by rounding to the nearest even number, we avoid consistently rounding up or down, which is going to help to balance out rounding errors over time. This is mostly applied when you are working with very large data sets. It's going to play a safe game by using this Banker's rounding. So if you really want to round this properly, so 2.5 should be 3, then what we're going to do is using a method called math, making reference to the model import, CEIL, and then this is going to run precisely what we need. So 3, if I change these to say, let's say 4.5, now we're going to get 5. And then if you do the same thing for 6.5, we're not going to get 6, which is something that will happen if you use the round. We're going to get 7. So that's what's happening. So round is going to round the numbers, but it's going to use it using the nearest even number, meaning, again, if you have 2.5, the nearest even number, it's not going to be 3, it's going to be the number 2. So it's going to completely ignore this 0.5. If you do 3.5, we're going to get the nearest even number. It's going to be 4, and so on. So I know it can be a little bit confusing, but just to explain the difference, because round can give you the impression that we are going to round up when everything is above 5 or above 5, but that is not what's going to happen. And I thought it would be interesting to point out this so you don't have surprise down the line. The next 2 functions that I want to point out, they don't have surprises. They are the absolute value. So the absolute value, what's going to do, it's going to give the absolute value, which in this case is the number 10. So it's going to completely ignore the minus here and give us this value. It works with integers. It also works with float numbers. So minus 10.5, the absolute value is going to be 10.5. And then finally, the last one I want to point out is we talked about the exponentiation, where we do the base number to the power of another number. Instead of doing this way, another option that you have is working with the POW function, where you're going to give the same information. So you give the base, it's going to be 4, and then you give the exponent, which is going to be 2, and then we're going to get the same value that we get if we were doing this arithmetic operation. So click apply, they go, we're going to get 16. We have a couple of more functions that we could cover. So for example, there is one that allows us to get the square roots of a specific number, where we can work with degrees and radians. But I think for now, this is a good introduction of the math model and also what you can do with numbers. So as a quick recap, we saw that we can work with integers, with float numbers. We also have complex numbers, which is not something we're going to use. And then we've seen the different arithmetic operations that we can do, including how we can work with the floor division, with the models, and the exponentiation operator. And then finally, we saw a couple of math functions that we can work with, but there is much more that you can explore on your own time. And I think with this, we can conclude this lesson, and I'll see you on the next one. Hello, and welcome to another lesson where we're going to dive into one of the core concepts of working with Python. And in this case is the use of conditional logic and control flow. Now, what exactly is conditional logic? Well, to give an example, we as humans, we use conditional logic all the time. If the weather is cold, then I'm going to use a jacket. If not, I'll just keep the t-shirt. This is a conditional statement. We're checking if condition is either true or false. And based on that, then we make a decision. And the same thing happens in computer programming. We use conditional logic to tell the computer how to make decisions based on certain conditions. And then control flow is the order in which the computer is going to execute the codes of block that we have in our script. So how do we check if a condition is either true or false? We also call this a Boolean. Well, for that, we are going to use what is called some of Python's operators. And in the lesson that we cover the use of numbers, we also talk about some Python operators called arithmetic operators. These are related with multiplication, subtraction, and division. But to check if a condition is true or false, we are going to use the ones we see here on your screen. We have the comparison, logical, membership, and identity. And each one serves to a different purpose. For example, the comparison, I believe, is the one which is easy to understand because you are literally comparing two values and see if they are true. So for example, here on the Python shell, I'm going to type 1 equal to 1. And notice the difference that we have here two equal signs. This is for you to check if it's equal. If you do something like x equal to hello, it's not an equal operator. This is an assignment operator. So to check if a condition is equal, we use double equal signs. So 1, so it's going to write again, 1, it's going to be equal to 1. And then what we're going to get in return is always true. Then, for example, if you check if 1 is equal to 5, you're going to get false. So that's what you're doing. You're comparing values. Obviously here I'm using very simple examples just for the sake of showing how it works, but you would be comparing variables to certain conditions. And of course, we can do more than just to check numbers. So for example, if I do something like Houdini as a string, and I'll say if it's equal to Houdini, it's going to say it's false because although the word is the same, in one I'm using all capital letters and the other one I'm using lowercase, so it is different. So it's something for you also to keep in mind. Obviously, when you see here, we have more options to check the values if they are, for example, greater than or less than. But then we get to this last one, which is called not equal. And this may be a little bit confusing because we already have an operator to check if a value is equal. So it's either going to be true or false. What is the purpose of us having another one that is going to give us the same result? Well, it has to do on how we are writing our codes and what exactly we want to check. If we want to focus on excluding values or validating inputs from the user, or for example handling possible mistakes, we tend to use more the not equal. Let me give you a very simple example. Let's say we are going to ask the user to provide us a file, but that file needs to be a specific file format. The script that we wrote only works with Alembic files. So I'm going to type here a variable, I'm going to call it file, and let's pretend that this is the variable that's going to store the file that the user selected. And instead of selecting the limbic file, it's going to select an FBX. So then how do we check if the user provided the correct information? How do we validate that information? Well, we could use an if statement and say if file it's not equal to ABC, then we're going to ask for the user to select an unlimbic file. And if you click apply, then you'll see select an unlimbic file. The reason why we'd be using the not equal is because we don't know necessarily what the user is providing us, because it could be an FBX, it could be OBJ file format, it could be a BGO, it could be a lot of things. And instead of creating a condition for all of those options, we are just saying, is this file not equal to an limbic? Then if it is not, you need to select the correct file. So that's one use of using the not equal. Moving on to the logic operators, these ones are quite easy to work with. And for these ones, we can start combining multiple operators together. So for example, going back to the Python shell, one thing that we can do is we can say 1 equal to 1. So this is one condition. And we want to check if 5 is equal to 5. And obviously, both conditions are true, so the result that we get is true. But see what happens if one of the conditions is not true. So if we say is 5 equals to 6, then we're going to get the false result. And why? Well, because with the AND operator, both conditions need to be true. If one of them is false, then the result we're going to get is false. There are situations, however, when one of the conditions could be false, but as long as the other one is true, the code can carry on. So for that, instead of working with the AND operator, we are going to select the OR operator. And with this one, we're going to get a true result, because despite the fact that 5 is not equal to 6, 1 is equal to 1. So for that reason, we're going to get the true as a result. So what about then this last one, the NOT? So what exactly the NOT does? Well, the NOT operator basically works like a switch where it just flips the Boolean value. This means if a value is true, the NOT it's going to flip it to false and vice versa. Let me give you a very simple example of how you can use this NOT. Let's say that we have a script where the camera is by default set to false. So the camera is not set in the viewport. But when we're running the script, we need to see if the camera is set. So how do we check that? If by default this value is going to be false, we are going to use the not operator. And the way you write it, you say if not camera underscore set, say print set camera first. And then when I click apply, you'll see that the result we're going to get is set the camera first. So how exactly this works? Now remember that the not operator is going to pick up this value, the false, and it's going to flip it. It's going to make it true. So in plain English, what you'll be saying is, if the camera is not set, then you're going to print this. Obviously, we will do something much more complex than printing this. We'd probably say, okay, if the camera is not set, then what you're going to do is you're going to set the camera for the user, for example. But that's the idea with working with a not operator. It works as a switch, and because it makes this value true, then this is executed. And perhaps just to help you to understand why it works this way, is Python only executes the code that you see here if this variable is true. If the condition is not true, then Python is going to completely ignore this. And you will see this a little bit in a moment when we dive into working with the if statements. But now let's move to the membership operators. The membership operators are extremely useful for us to check if a value exists or does not exist on, for example, strings, on a list, or on a dictionary. So it's a great way for a search for those values, to filter data, to validate user inputs. And the way it works, I'm just going here to the Python shell. The way it works is you check, for example, if A is in ABC, and then obviously it's going to say, well, yeah, it's true. But if you would check F in ABC, that is going to say is false. And then if you want this value to be true, you would use the not in. So for example, if you do the same thing where you say not in, then instead of false, we're going to get the true. So that's the difference of working with the membership operators. And then finally, we have the identity operators. And for this one, I'm just going to paste here some code. It is nothing special. It's basically two lists, and they have the same value. And if you're looking at the identity operators, you'll see that A is B. It means as A is the same as B. And then in the first instance, you may say, yeah, that's true. If you use these, you would just expect this to be true. So let's see what happens if we print A is B. You'll see that the result we're going to get is false. But A is equal to B because both of them have the same value. And it's easy to confuse the is operator with the equal. If I would replace this with the equal operator, then you'll get true because the values are the same. But what we're doing with the identity operator, we're not checking if the value is equal. What we're doing is we're checking if two objects, they reference the same memory location, or basically in simple English, if the two objects are the same object. So here we'll see that if we say A is B, it's going to say it's false. If you would do something like this, where B is going to be equal to A, and then you check again the value, now you're going to get true, because now we are pointing to the same object. And just to be easy to understand, what I'm going to do is I'm going to use a function called ID, and here I'm going to put the A variable inside, and I'm going to do the same thing for the B. I'm going to remove this line, and then I'm going to ask to print, and then you'll see here down the line, just going to move this up a little bit here, you'll see that we have two values. We have the value for A and we have a value for B, and they are completely different, these ID values. This to show you that they are not the same object. There are situations where we may want to use the identity operators, although I think this is not something necessarily we're going to do in this workshop. But the reason why you need these identity operators is to help you to debug some object reference. When we are working with mutable types like lists and dictionaries, this can help us to verify if the two variables are pointing to the same object. But they can also be used for optimization. For example, we can ensure that we're not creating unnecessary duplicates, which can save memory. There are some situations where we can use these identity operators, but I would say that most of the times we're probably going to be using the comparison, logical, and membership operators. Okay, so we know how to use this conditional logic. We're checking if a condition is either true or false, but then how do we use this in the practical way? Well, for that, we are going to dive into control flow, which is the way that we control how the code is going to be executed. And for that, we use what is called the if statement. And the if statement tells Python to execute a block of code if the condition is true. So if we start with something very simple, we need first the if keyword, and then after that we put a space and we provide the condition. We can say x equal to 1 here, and then here we can ask, is x equal to 1? This is the condition. And then after the condition, you put the column sign, and then you press enter to get a new line, and you press the tab key to get some white space. This is called indentation, and you need this for the if statement to work. And then here you put your codes. And for us, we're just going to put something very simple. We're just going to print the message yes. So what's going to happen here in very simple terms? Python is going to read the if, and as you're checking if a condition is either true or false, it checks the condition and it's going to check is this true or false. If this condition is true, then it's going to check, it's going to execute the code. In this case, it's going to print yes. So if you do that, you're going to get yes. This is all you need to do to work with if statements. You don't need to do anything else, but there are situations where you need to add some extra statements for the code to work. Because what happens is, if x is equal to 5, for example, if we're checking this, nothing is going to be executed. You'll see if I put a couple more lines, if I press apply, this is not executed. So what happens in a situation like this? Well, for this, you could then use the else, and the else works as a safe net, let's say, because if the first condition is not true, then you're going to execute a different piece of code. And in this case, we're going to print something saying no. So if I click apply, you'll say now we get the no value. And that's how it works. By default, you don't need the else statement because if you assume the condition is going to be true, then you just need this first section. But in some situations, we may need to work with the else. But then one thing that we want to avoid is what we call the nested ifs, because after the else, you can add another if check. Let's say if x is equal to 0, and if it is, you print is 0. And if you do this, then you click apply and you see nothing is happening because, again, this condition is not true. So then what you can do is add another else, and here you're going to say print is not 0. So now what's going to happen, if you click apply, you'll see that we get the message is not 0. But if you really need to check another condition, what you can do is you can put another if inside. And this time we're going to say if x is greater or equal to 0. And if you say we're going to print finally, and then when you click apply, you get finally. This is not something that is recommended to do because it can make your code difficult to read and to maintain. It becomes difficult actually to predict what's going to happen with the flow of the program. Obviously, this is a very simple example, so when you see it, you can understand what's happening. But if you have lines of code between each if and else, it becomes very difficult to understand what's happening. So in a situation like this, if you need to check multiple conditions, then what you have to use is the elif. And the elif, you type it like this, elif, and basically what this is doing is check if this condition is true, if the first one is not, it wasn't true. So if we do something like this, if we do elif x equal to 0, it works the same way. Then you do the indentation and you say print is 0. And then what you have to do is you have to select these codes and you have to push it back for work. If you don't do it, we're going to get an error and say that there is an invalid syntax because the way Python works. So the way you can do it is if you select the codes and you press Shift Tab to go back, this will just put the indentation on in the correct position. But you'll see that if you click apply, then we are going to finally, because it is executing this one. But instead of using else and then another if inside, what we can do is we can put another elif, and then we push the indentation back, and when you click apply, we're going to get finally. So this is finally work. And in a situation like this, you don't need to use an else statement. But if you want to have as a safe net, that is something that you can work with just in case something could go wrong. Well, talking about something going wrong, sometimes we can predict that a piece of code will fail. A very simple example of that is you ask the user to select a file, but instead of selecting a file, the user just closes the window or clicks the cancel button. So how do you handle that? Because if that happens, and if you're not prepared, the program is going to stop, it's going to crash, but we can use what is called the try and except statement to handle this type of errors. And the way it works is you start by typing the try keyword, you put a column on front of it, and you say, okay, try to do a file, for example, open, and then we just put something here to pretend is a file, and then we can say, print file, for example. But if the user closes the window, then we use the except, and the except is going to look for the error we're going to get. So if we say file not found error, then you can put another print and say select a file. In our case, we could, with Houdini, you could use something like the UI and put like a displayed message. Just say, open a file. So this is how you can handle this type of situations. Obviously, inside you then could put, since we're talking about the if statements, this is related, you could put something like just the code that you want to run. But in case there is a mistake, the except will work as a safe net for you, just to make sure the program can carry on and not crash. Okay, so in conclusion, what we learned on this lesson? Well, first of all, we saw that we can use these operators to check if a condition is either true or false. And then based on that information, we can control how the computer is going to make decisions using the if statement. The if statement, the way it works, you start with the if keywords, then you're going to put the condition you want to check with a column, and you put the code you want to execute it here. This code is only going to be executed if the condition is true. If the condition is not true, then you can use the elif to check for another condition, for example, something like this, and then you're going to put the code here. And then if this condition still is not true, you can put another safe net, which is the else. And this else is where you put another code just to make sure, like in case none of these conditions are true, how you can handle. The elif is a great way for you to avoid having nested if statements, not because that is necessarily something wrong, but because something is make very difficult to read the codes and to maintain it. So it's better to use elifs. And then finally, we saw that there are situations where we want to run this type of decisions, but the user made something that is going to crash the program. So for that, we can use the try and except statement. The try is going to run the code that we're expecting to work, and then the except is going to catch the error and provide some information on how to fix that error. And this is the basics that you need to know on how to work with conditional logic and control flow. Obviously, there is more things that we could dive into, but for now, I think as an introduction, it will be enough. Hello and welcome to another lesson where we're going to dive into one of the core concepts of working with Python, which in this case is the use of lists, tuples, and sets. So lists, tuples, and sets are part of built-in data types in Python that we use to store a collection of data of information. There is another one, which we're not going to cover in this lesson because it works slightly different, which is called a dictionary. So in total, we have 4 built-in data types. And on this lesson, we're going to focus on working with lists, with tuples and sets, and see when we should be using one and not the other ones. So as you can see here in your screen, we have examples of how to create these data types. So to create a list, you start with a square bracket, and then inside you can put some text or numbers or a Boolean value, for example. And then once you finish adding the item, you use a comma, as you can see here, and then you put the next item, and so on and so on. A couple of things that we can keep in mind with lists is that we can have duplicate values. So for example, here we have this is not a mistake, this is on purpose. We have the word dot repeated twice. And then the other things that works with lists is the fact that they are ordered, so they have a specific index for each item that we have on the list. And then the other thing is with lists is that you can add more information or remove if you want. So let's ignore for now the tuple and the set. I'm just going to comment this out, and then we're going to focus our attention of working with lists. So to work with lists, we use something called methods. We saw the same thing when working with strings. So with lists, we have the same thing. Now, to have access or have an idea of the methods that are available, a quick thing that you can do is you can use the dir function. And then between the parentheses, you're just going to copy and paste the variable that represents a list. And then when I click apply, we are going to get a very long list of text. But the things we're going to focus are this last section here. So everything that has the double underscores, just completely ignore it. We're going to focus on the ones we have here. So we see we have, for example, append and insert. So what you can do with this is add more information. And there is a slight difference between these two options. So if I go here and I do my list, and let's start with the append, and in the append, I'm going to add a value ROP. And if I print now my list, you'll see that this list is going to be slightly different because we're going to have a new value, but that value here is going to be added to the end of the list. So that's how it works with the append. It's always going to be added automatically to the end of the list. But then you also have the option to insert information. Now insert works slightly different because you can specify where you want to insert this new item. And for that, we are going to use an index. So if we want, for example, to add this ROP value to the beginning of our list, what we can do is using the value 0 just to indicate where this is going to be, and then you put a comma, and then you put what information you want to add. So now if I click apply, you'll see that ROP was added to the beginning of the list. And this is a good segue for us to talk about something that you can do with lists, which is access information inside the list. And the way you can access that information is precisely using indexes. So for example, here I have my list, and if I want to have access, for example, to the second value, what I'm going to do is I'm going to open with the square brackets. I'm going to put the value number 1 and then close with square brackets again. And remember, I think I probably just repeated this a couple of times in our lessons, and the way it works is the value 1 is not your first value. So the value 0 is going to be the first item in your list. So 1, it's going to give us the second value that we have in our list. So if I click apply, we're going to have the word SOP. And why is that happening? Well, because we are inserting ROP first. So if I comment this out and I click apply, you'll see that looking here, we are going to get the word LOP because this is the second that we have in our list. You can also do something called negative index, and for that we're just going to use the minus. So this is going to give us the last value. So if you click apply, now you're going to get the word true. And similar to what happened with strings, there we can do something called slice. We can do the same thing with the with lists. So for example, the way it works, you started by providing with the first index, and then you use a column. And then you need to provide the second value for the slice. And the way it works is the fact that, for example, if we want to provide this third value, so 0, 1, 2, we need to provide another value, for example, to number 3. And you'll see in a second why. So if I click apply, you'll see that we got SOP, LOP, DOP. And this number here can be a little bit deceiving because the index, if it gives the feeling that you're also going to include 0, 1, 2, 3, but in reality, the last number that you're providing, it's not going to be included. So that's something to keep in mind. But this is what you can do, which is called slicing using lists. Now, more things that you can do with lists, you can remove. There's 2 ways you can remove information. So if I go back here, and if I just remove this slicing from here, you can use the pop. Now the pop is going to work, there's 2 ways it can work. So if I click apply, this is going to remove always the last value that you have on your list. Or then the other option is for you to provide an index. So for example, if we want to remove the SOP, I'm just going to provide the index 0. I click apply, and then SOP is removed from this list. Then you have remove, and remove, the way it works is when you want to be very specific, and for example, if you want to remove LOP the same way, then this is going to remove LOP from our list. So 2 ways to do the same thing, they work in slightly different ways. Now, one thing that you can do with lists, and that's why they are very practical, is that you can loop through this information. And this is very useful. For example, let's say we select a bunch of FPX files, and then we need to bring those FPX and we need to create a file node for that FBX. We need to apply, for example, a match size. There's a couple of steps we have to follow for every single one of these assets. So for that, we can work with a for loop. In a for loop, you start with a for keyword, and then you assign a variable. This is one of the few occasions where you can just use a letter, for example, X. I personally like to use something a bit more specific. So for example, item in my list underscore my list, and then you put the column at the end. Press enter for a new line, tab for the white space that we need, and then what we're going to say is we're going to say print item, and this is going to do, I'll give a couple more space here. What this is going to do, this is going through every single item in this list and is going to print it. So there you go. We have all the information we have. Obviously, we're just printing information, but in the real world scenario, we would be doing something with this information. There is just two things I want to cover before we move into the tuples that are related with working with lists. Is the fact that you can convert a list into a string. So for example, if I remove, let's say, this information from here, the way you can do that is by creating, for example, a new string, and we're going to start with the double quotation marks, and then inside here we are going to provide what we want to use to merge this list into a string. So for example, if you use a comma, then between every single word we're going to get a comma. But if we work, for example, with the space, then we can do dot and join, and then we open parentheses, and inside we are going to select my list and then close, and then we're going to print, and we're going to print a new string. And then when I click apply, you'll see that we have, this is converted as a string. For example, instead of the space, if I put the comma and I click apply, you'll see now between each word we have a comma. So you can convert a list into a string, but then there's something else that you can do, which is quite useful, is converting a string into a list. So what I'm going to do, I'm just going to copy the output that we got here, copy. So this is going to be our new string, and I'm going to put some extra information here, so just for the sake of you seeing it. And initially I'm just going to do through and then hello, for example. So this is a string, and now to convert this into a list, what we're going to do is we're going to just copy the new list here, put it inside the print as well, and then new list is going to be equal to the new string, and then you use the dot split, and here you have to specify what you want to use to make this split. So in our case, we have a comma between every single word, so we provide that information. We want to use the comma, and then we close with a double quotation mark, we close with a parenthesis, and now when I click apply, you'll see that we converted this string into a list. And you may be thinking, why is this useful? Because there are situations when we ask information from the user, we're going to get that information as a string and not as a list. So we need to convert that string into a list. A simple example would be, we have a path to a file, for example, something like this, right? We're going to say, instead of using the comma, we want to use the backslash. So we're going to provide that. And then when I print my list, you'll see that we just converted this string into a list. And then, for example, if we want to just grab the name of the asset, then we could use the index -1, because we know that the asset is always going to be the last one. So when you do this, then this is going to provide us the asset.fbx. And this is how we can work with lists. Now let's go to the second data type that we can work with, which is the tuple. So to create a tuple, we do the same thing that we do with a list. We can have duplicate values, we can have strings, integers, floats, we can have booleans, but instead of using the square brackets, we're going to use the parentheses. So you start and you end with the parentheses, and then you have a tuple. Now, what is the difference between a list and a tuple? The difference is that you can modify a list, but you cannot modify a tuple. So once a tuple is created, that's it. There's nothing that you can do to change the information inside. And as a matter of fact, if we do the same thing that we did for the list, if we check what kind of methods are available to work with a tuple by using the div function, and I click apply, you'll see here that we only have two methods to work with a tuple. So there isn't much that you can do with a tuple. And the benefits of working with a tuple is when we need to work with information that is not going to change and cannot change. For example, when we ask Houdini to provide us a list of the points for a specific geometry, that information it's going to be given to us as a tuple. And it makes sense because it's not possible for you without going in a proper way to just add a new vertex or a new point to that variable, and suddenly this piece of geometry has a new point coming from nowhere. So the way for Python to protect itself is by just providing that information as a tuple. Obviously, we can convert a tuple into a list. One way we can do that is by using the tuple function. So for example, if I do my list, it's going to be equal to list my tuple, and then I'm going to print my list. You'll see that we converted a tuple into a list, and you can do the same thing. So you can convert a list into a tuple. So for example, if we do the same thing here, so my list, and it's going to be my tuple, and we're going to comment this out, and instead of list, we're going to use tuple, and here we're going to put list and print my tuple. You'll see now we converted the list into a tuple. So that's one way that you can work with information that Houdini is going to provide you. But let's get back to the tuple. And I know I said that it's not possible for us to change what is inside once we assign the tuple, but there is a hack that you can do, and it's precisely by doing what you just saw. We convert the tuple into a list, we append the information that we want to that list, and then we convert it back to a tuple. So very quickly, what I'm going to do is I'm going to create a new variable. So let's say new list. It's going to be equal to list, open parenthesis, copy my tuple inside. So now if I print this, you'll see this is the list. And then let's say we want to do new list, append, and I'm going to wrap, and you click apply. Now we have wrap. So then you'll say that a new tuple, or even my tuple if you want to, we can overwrite this and say that my tuple, it's going to be to tuple, open parenthesis, inside you put new list. And now when you convert and print this, you'll see that we just converted a list into a tuple, and now we have the information inside. So this works like a hack in a way, because as you can see, there is no way for us by default to add or remove information from a tuple. Now, one thing to keep in mind is the same way that we can loop through a list, we can do the same thing with a tuple. So by using a for loop item, and then in my tuple with a column, new space, and then you say print item. It works precisely the same way that you can work with a list. And now let's move to the last one, which is a set. Okay, so a set is very useful. For example, if you want to remove duplicates, we know that here we have the dop, which is repeating twice. But then if I print my set, you'll see that this is going to be removed. So it's a great way for you without having to just write extra code, for example, in a list, and go and remove any duplicates. You can just store the information as a set. So if I click apply, give a couple more lines, apply, you'll see that the dop was completely removed. So that's one of the key points of working with a set. The other thing is you don't have a specific order in a way for you to access the information. I know here when I printed, we kept the same order. But for example, if I try to go here and try to access the value 0, we're going to get an error because it's saying this is not possible. But one thing that the sets are quite useful is when we want to use the membership operator to check if the information is inside. And if you haven't watched that lesson about working with the if statements, here's just a quick recap. You can do if, and you can say sub in my set column, a new space, print yes, and click apply. You'll see that we're going to get a yes. But you can do the same thing with a list, right? Yes, but the difference is that it's more efficient to work with a set. I know the example that we have here, this set is very small, but in situations when we need to handle large data, sets are faster for membership tests comparing with lists, make them very useful for us to handle large data sets when we need to frequently check for existence of an item. Then the difference, the set, for example, with the tuple is the fact that you can add more information to the set. Let me just go here and do print, and we'll do the same thing, use the dir function, and inside I'm going to put my set. And here we can see the kind of methods we have available to work with. So we have, for example, the pop, we have the remove, we also have the add, the insert. So they work very similar to the same things we did with the list. So for example, if I want to add more information to this set, what I can do is I can just copy my set, and I'm going to use the add method. And the way it works, you just add, and I'm going to add ROP. And I don't know why I keep going back to ROP, but it's just for the sake of an example. And then when I click apply, and let me click apply again, you'll see, I don't know why we're getting this, but let me just create a new Python shell. And I think it may be a bug. So if I click apply, you'll see that what we have now is the word ROP inside. But there's something interesting, is that the order in which we have the information in our set change. And this is one difference that we have from lists and tuples, is that the order of the information inside the set, it can change. So for example, if I add more information inside, let's say if I add a number, if I click apply, you'll see now the number is first, then we have dop, lop, sop, rop, but it's completely different from the previous one. And this is one of the difference between a set and a list and a tuple, is the fact that the order is going to change. And that's the reason why with sets, it's not possible for us to work with index. So if I try, and again, I'll show you this already, but if I try to put an index here, we are going to get an error because that's not how sets work. So this is just a brief overview of how we can work with lists, with tuples and sets. Obviously, throughout this workshop, we are going to see practical examples of these data types in action, and then also check the lesson where we're going to cover the dictionaries, because they work in a different way, and I thought it would make it easier and less confusing to talk about dictionaries in a separate lesson. So to recap, we have list, tuple, sets. They are ways for us to store information. Each one of these data types has a specific way to work. So for example, with lists, we can change it, we can add more information, we can remove information. With tuples, it's a little bit different. We have a specific order, the same thing as we have with lists, but we cannot remove or add information. They are kind of like a lock in the one list we created. And then we have a set, which is kind of like a wild horse, because the order of the items inside can change. You can add information, but contrary to the tuple and the list, you cannot use index to get information from a set. Obviously, there is more things that we could cover. There is more methods for the list and the sets. But my recommendation is, if you want to learn more about these methods and what they do, just go to the W3 schools, for example, the Python section, and you have more information there. What I cover on this lesson is what I think is the most useful and what we're going to use most of the times. There are other things you can do with these data types, but they are not so common, and that's the reason why I didn't cover them in this lesson, so that this lesson wouldn't become too big. So with this, we are going to finish this lesson, and I'll see you on the next one. Hello and welcome to another lesson where we're going to cover one of the core concepts of working with Python, and that is the use of comments. And comments, it's something super easy to create. All you have to do is press the hashtag key and then you write your comment. Now the cool thing is that Python is going to completely ignore anything that is written as a code. So if I click apply, that's it. You're not going to see it. Now, why is it useful for us to use comments? This is one of the key aspects of writing good code. It's using comments to add notes to your codes, to explain what you are doing, to make the code more readable, and also is a way for you to prevent executing some of the lines if you are just testing the code. So for example, what I mean by that is if you say print, and you're going to print Houdini, if you want to prevent these to be executed, then all you have to do is just comment this out. So when you click apply, nothing is going to be printed. In the Python source editor, one thing that you can do, for example, for x in range 10, print x. So see, this is going to print x 10 times. If you want to prevent this code to be executed, then all you have to do is select it, and then you'll see here this hashtag icon. If you click it, this is going to add the hashtags just to completely remove it as a comment. And then if you want to remove the hashtags, you just press the other button, it's just going to remove it. Now, comments are something extremely important to use on your code. This is something you have to keep in mind, is that you know what are you doing at the moment, but then trust me, in a week, if you haven't touched that code, and I'm not talking about a script with 100 lines, obviously, I'm talking about with scripts with thousands and thousands of lines. In a week's time, you have no idea what that code is doing. And there is a famous joke for programmers that when I wrote this code, only God and I knew how it worked. And now only God knows it. And that's exactly to highlight the point that in a week, in a month, in a year, when you get back to some of the codes, you have no idea what the code does. And if you don't have any comments, I can say it's almost to the point where you kind of have to rewrite the code again to understand what you are doing. And that can take a long time. So leaving comments, it's something is going to help you, and you'll see they're very easy to use, but there are a couple of things you have to keep in mind. Comments are not the way for you to explain poorly written code. So for example, let's say if you have something like for x in n, and then you say very simple print, and then what you don't want to do is adding a code and say, hey, n is the number of cameras. Okay, this is not good code. And why? Well, for several reasons, but the main one is the fact that if you don't need a comment to explain that n it's a variable for the number of cameras. If you want to write good code, then this variable should be the number of cameras, and that's it. That's the point of using good names for the variables. And if you haven't watched, you should watch the lesson I did about using variables and how you can write good names for the variables. But that's the point to keep in mind. You also don't want to have something where you just explain every single step. This is a loop to print all the cameras. You don't need to write this. This is information that adds nothing to the code. Of course, and this is something I want to highlight, is when you are learning, it does make sense for you to kind of have these comments in order to help you to understand what you're doing. So as an example, I'm just going to paste here what you can do is something like this. So if I just move this correctly, this is perfectly normal. When you're learning, you want to almost explain line by line what you're doing, but this is not something you want to do when you're starting create codes and you are sharing this code with other people. This is not good practice in terms of adding a comment to every single line what you're doing. The purpose of working with comments is mostly to explain why you are doing something, than rather how you're doing something. Now, just another thing I want to highlight is the fact that in Python, you don't have necessarily a specific way to do multi-line comment. You don't. So some language you would start with a specific character, and then that allows you to write a lot of comments, and then you'll just close again. This is not possible with Python. So all you have to do is just using the hashtag. You write something, and then if you want to add another comment, you'll just do this is another comment, and that's basically it. That's how you create multi-line comments. Now, another way that you can document your codes is by using doc strings, and doc strings is something that you use to provide descriptions to model classes, methods, and functions. It's a good way for other developers and yourself in the future. Trust me, again, the point that in the future you will appreciate you leaving these comments for yourself. But the doc strings helps you to just create something that you can refer it back. I'm going to copy and paste a very simple example. This one here. This is how you create a doc string. So you start with triple quotes, and then you write your documentation. Technically, this is a string. It's not a comment, but the purpose is to comment the what are you doing with these codes. So how is this useful? Well, first of all, when you are reading the codes, this gives a description of what this method or this function is doing. And then there is something else that you can use to access this information. So if you type print, and then between the parentheses, you give the function name, and then in front of it, you use the double underscore, doc, and then again, double underscore, and then you close. You'll see here what's going to happen. You're going to get this text printed. So this is a very useful way for you to have access to the information of the specific function, and is a great way for you to add comments or documentation to your code. So in conclusion, why do we use comments in Python? Well, first of all, comments help others and yourself to understand what's the purpose and the functionality of the code, but just clearly stating the reason behind it. Comments, it's not a substitute to poorly written codes. It's not a way every single line you explain what are you doing. You use comments to document the code. We'll see here, for example, with doc strings, it's a great way to do that. You can also use comments. For example, if I put the hashtag here, this is not going to be executed. We're not going to get any output. So it's a great way for you to troubleshoot codes. You saw that if you want to add comments or, let's say, disable a section of your code, all you have to do is select everything. And then in the PySource editor, if you click on this button, it's just going to comment out. And then if you click on this button, it's going to remove the comments. You should be using the comments to sometimes explain complex algorithms or the logic behind some of the codes. Or if you're working with a loop or with nested loops or with if statements, it's a great way if it's just you briefly explain why you are doing this and not necessarily how you are doing this. And then the other cool thing is the fact that even if you don't have this doc string, what you can use the comments for is to precisely explain what are you doing with this function. And this is very useful because you don't have to write the same code over and over and over. you can go back to previous stuff that you did, and then because you're using comments and you are explaining what that function is doing, you can just grab that code, that function, bringing it into a completely different script. But because you explain clearly what you're doing, it's very easy to reuse codes. So this is the basics you need to know: how to work with comments, how to create them, and why you should be using comments. And with this, we conclude this lesson, and we are ready for the next one.